Hello and welcome back to the course on blockchain. Today we'll find out what a blockchain is at a high level. So, blockchains, where did they come from? Well, the concept initially came from these two people. They didn't necessarily coin or introduce the term blockchain. That came much later after the original paper by Satoshi Nakamoto. But these two gentlemen over here, Stuart Haber and W. Scott Sternetta, in 1991 published a paper called How to Timestamp a Digital Document. And if you look through that paper, if you read through it, you'll find that the concepts of what now we call a blockchain and all of the, or most of the features and ideas behind the blockchain actually are present in that paper. And the way Wikipedia identifies a blockchain is a continuously growing list of records called blocks, which are linked and secured using cryptography. So this is a very general definition. There's much more to a blockchain, as we'll see, but this is already some place for us to start. So let's have a look at one of these records, or so-called blocks. What constitutes a block? Well, a block, because it's a record, will obviously have data inside it. For instance, it might have just a string of words, hello world. Then it'll have a value, which is called a previous hash. And we'll get to this in a second. And then it'll have a value, which is its own hash. And what the hash is like a fingerprint of this block. It's like taking the first two elements, the data and the previous hash, and finding a number which represents that data. So a shortened version of the data, specifically it's 64 characters long. And we'll talk about hash more in the future, but basically right now the best way to think about it is a digital hash is like a fingerprint of some amount of data. And that makes it much clearer, or makes it clearer now what's going on. So the block here has its own hash, and then the previous hash, which is contained within the block as a reference, is actually the hash of the block that came before it. So let's have a look at that in action. So here we've got block number 1. It's also called the Genesis block in a blockchain, the first block. And it's called Genesis block because after the blockchain is initialized, that block will always stay block number 1 forever and ever and ever, for eternity. It will never change. That's no other block will become number 1, so this block is always going to be the first one. That's where it all originated. You might have some data in it. We're not going to go into detail what kind of data is in there, but assuming there's some data, it doesn't have a previous hash inside this block because this is the Genesis block. It's the only block that won't have a previous hash, so we're just going to represent that all zeros, and then it will have its own hash. Again, for now, let's think of hash as a fingerprint. We'll find out more about how these hashes are derived in a coming tutorial. And then there's block number 2. And block number 2 also has some data. This time it does have a previous hash, and it has its own hash again. And as you can see, the block is, the previous hash of block number 2 is exactly identical, or is exactly block number 1's hash. And that is where the link comes. That is why a blockchain is called a chain, or a blockchain, because the blocks are cryptographically linked with each other through these hashes. And again, more of that on that to come, but this is conceptually how it works. Every block has its own fingerprint, and it also references the fingerprint of the previous block. So if anything were to change at block number 1, its fingerprint would change. So if anything were to change here, anything were to change in the data, so somebody were to tamper with the data, this fingerprint would change, and it would no longer match this fingerprint. So this block would know, or we would know by looking at this block, that somebody tampered with this block. And then again, block number 3, data, it's got the previous hash, it's got its own hash, and it's linked to the previous one, and so on. So again, conceptually, we can see that if anybody were to tamper with any block, this one or this one, then the fingerprints would no longer match up, and the chain would be invalid. The chain would show that there's something wrong, and that's why that's why we say that blocks are cryptographically linked together. All right, so that is a blockchain at a very, very high level. To get us started, there are many more concepts to blockchains. Things like mining, distributed peer-to-peer network, consensus protocol, immutable ledger, and hash cryptography. So right now, many of these might sound very alien or very confusing at the moment, and that's totally fine because we're going to go through them one by one in the coming tutorials and debunk all myths and understand exactly how everything here works. And we're going to start in the next tutorial with hash cryptography. But for now, if you'd like to learn a little bit more about blockchains from the original source where the idea first came up, highly recommend checking out the paper called How to Timestamp a Digital Document by Haber and Sternetta. The link's here, and also the link is going to be in the course notes, and you'll be able to just click it there and go ahead to the paper if you'd like to check it out. And on that note, I look forward to seeing you in the next tutorial, and until then, enjoy blockchains.